Hello friends, we are back with the second edition of vectors. In the last video session in my channel, you have seen that I have described about vectors. I have described about dot product, cross product, what are the properties of dot product, what are the properties of cross product. Okay. So that was a very preliminary discussion about vectors. I'll tell you more if you allow me to have a live session, about 1 hour live session. That will be good. That will be very much interactive. So let us do some small maths. Okay, that has already appeared in JEE. Some small maths about 4 or 5 problems. Let us do based on the concepts that we have gained in the last session. Okay. See the first problem, that is it is given, it is in front of your screen, that if two vectors p and q are perpendicular to each other, then the value of m will be, okay, one of the 4 answers, it will be there. So the vector p and q are perpendicular. So if it is perpendicular, what does it mean? Shall we go for cross product? Shall we go for dot product? Like if we know that if it is dot product, that is p dot q, that is mod of p mod of q cos theta. Okay. And if it is p cross q, then mod of p mod of q sin theta. Okay. So perpendicular means 90 degree, 90 degrees. So cos 90 is 0. So let us try to solve it this way, that I'm just writing that vector p dot q is equal to mod of p mod of q cos 90 degree. So cos 90 is 0. So this turns out to be 0. Okay, so how we have solved dot product, that I have already explained. Please have a look in the earlier video how dot product was explained. Okay, we have seen that ijk, the unit vector in the direction of x, the unit vector in the direction of y, and unit vector in the direction of z, these 3 unit vectors are positioned in directions which are mutually perpendicular to each other. Okay, please don't have any confusion on this things. So let us see how that dot product can be calculated. In place of I am writing I plus 2mj plus mk dot 4I minus 2j plus mk, that turns out to be 0. Now if I am executing that dot product, we know that I dot I is 1 and I dot j or I dot k is 0, because I, j, k are positioned in 3 mutually perpendicular axes. So the angle between the 2 axes is 90 degree. So cos 90 is 0. So the dot product of any unit vectors which are mutually perpendicular turns out to be 0. So if I execute that, so I can write that 4 into I dot I. The other things is 0. That is why I'm not calculating that I dot j. That is, if you just multiply this two, that turns out to be 0. Okay, similar the case for other things also. So so only that I dot I comes out. Similarly, for like minus 4m j dot j, okay, and plus m square k dot k, okay, is equal to 0. So in place of I dot I, in place of j dot j, in place of k dot k, I am writing 1. So it comes out to be 4 minus 4m plus m square equal to 0. Okay, I'm writing m square minus 2 into 2m, it can be written, okay, plus 2 square is equal to 0. So that is a minus b whole square. So that is m minus 2 whole square is equal to 0. So m comes out to be 2. Okay, so the answer will be B. Okay, that is how you solve it. We'll go to the next problem. It is shown that 3 vectors, vector OP, vector OQ, vector OR, are given. It is having equal magnitude, okay, equal magnitude A, are acting as shown in figure. The resultant of these three vectors, okay, is A root x. So the resultant is shown to be A root x. We have to find the value that is inside the root, okay. So how to do that? First, let us find out the resultant between vectors P and Q. What is the resultant between vector P and Q? That is known to us. Vector P and Q resultant. So that resultant I am writing as vector R PQ is equal to root over P square plus Q square plus 2 PQ cos 90 degrees. So cos 90, again it is 0. Let us assume that, okay, it is of magnitude A. So we can write that this becomes root over 2A square. So this becomes root 2A. Because all the vectors are having equal magnitude, that is A. That is why I am writing A in place of P, A in place of Q, like that. So the vector RPQ, that is the resultant of the vector P and Q, that will be heading in which direction? If I see here, that will it not be heading in this direction, like in this direction? So that direction is the resultant of PQ. Now I have to find that the angle or the resultant between the resultant of PQ and R. So, but what is the angle? The angle between this is again 90 degree. This is again 90 degree. Okay. So keeping in mind this thing, if I find another resultant, that resultant now, the resultant with the help of like with PQ and R, that turns out to be root over root 2A whole square plus, in place of R also I am writing A square because of same magnitude, A square, and cos 90, of course it is 0, so I am not writing the next step. So this becomes root over 2A square plus A square. So that becomes root over 3A square, that is A root 3. So in the problem it is given that the resultant of all these vectors is A root x. So inside root it is 3. So the value of x is 3. Okay. That is how we understand things. Let us go to the next one. So let us go to the third problem. In the third problem, you see what is given to us. It is given that the magnitude, there are three vectors, OA, OB and OC. Now OA is at an angle of 30 degree with x-axis, OB is at an angle of 60 degree with x-axis, OC is at an angle of 45 degree with x-axis. Okay, that is given to us. Now we can consider the magnitude of all the vectors to be m, small m. And we need to find out the direction of OA plus OB minus OC with respect to x-axis. Okay. So let us break it down into components. The components, one along x-axis, one along y-axis. So let us break it down, and after that we will just execute that relation, that is OA plus OB minus OC. Okay. If I start to break it down, it stands out to be OA becomes m cos 30 degree I. Cos 30 degree is along the positive x-axis, that is why plus m sin 30 degree j. Okay, both are positive because both are along the positive x-axis and positive y-axis. Now this can be written as m, if I am taking it common, cos 30 it is root 3 by 2 I plus sin 30 it is 1 by 2 j. Okay, similarly OB can be written as m cos 60 degree I, positive x-axis, this will be minus because the y component will be in the negative y-axis, that is why minus m sine 60 degree j. Okay, if I'm taking m common out here, okay, so cos 60 degree, that is 1 by 2 I, okay, minus root 3 by 2 j. So that is OB we got. Similarly, if I write OC is equal to, OC is towards negative x. So OC will be minus m cos 45 degree I, and it will be positive y. So plus m sine 45 degree j. So if I take m common from here, minus 1 by root 2 I plus 1 by root 2 j. We got these things. Now, as per the expression, we have to find out that OA plus OB minus OC. So, OA plus OB, vector OA plus vector OB, this also you can write it as vector quantities. Vector OA plus OB minus OC. If you execute all these things, it turns out to be MI. Just I'm taking bracket I, root 3 by 2 plus 1 by 2 plus 1 by root 2 plus MJ 1 by 2 minus root 3 by 2 minus 1 by 2. I have to find the angle for this. So tan theta will be the ratio of that jth quantity by ith quantity. So tan theta will be m 1 by 2 minus root 3 by 2 minus 1 by 2 divided by m root 3 by 2 plus 1 by 2 plus 1 by root 2. M gets cancelled out in the numerator denominator. If I am taking, this comes out to be, okay, that is fine. So in the numerator, it comes out to be 1 by 2. Okay, this one stands to be, the next one is also root 2. This was also root 2. So this is also root 2. So this comes out to be, if I take the LCM, and this root 2 can be multiplied and divided by root 2 from either side. So that turns out to be, if I am taking divided by 2, this is 1 minus root 3 into root 2 by root 2. So minus root 2 divided by here also similarly root 3 plus 1 and into root 2 by root 2 plus root 2 by 2. Okay, so this you can further simplify this. We can just write here as if I just 1 minus root 3 minus root 2 divided by 1 plus root 3 plus root 2. Okay, plus root 2 and tan inverse that will give you the answer. Okay, fine. Okay, let us go to the next one, that is problem number 4. Here what is told to us, two vectors x and y have equal magnitude. Okay, the magnitude of x minus y is n times the magnitude of x plus y, and we need to find out the angle between the vectors. Okay, so what is given to us is the magnitude, that is magnitude of x is equal to magnitude of y, and what else, that is magnitude of x minus y is equal to n times x plus y. Okay, the magnitude of x, I'm writing simple x for the sake of understanding. Now this equation, if I'm squaring on both sides, what I'm going to get, that is x squared minus 2xy plus y square is equal to n square into x square plus 2xy plus y square. Okay. Now this becomes, if I take n square on the other side, so this becomes 1 minus n square into x square plus 1 minus n square into y square, and on this side it is 2n square 2n square plus 2xy. Okay, and x and y are having same magnitude, so xy is like a dot product of x and y of two equal vectors, so that will also square out. Okay, so x square, y square, xy, all these things gets cancelled. Okay, so what we are left with, if here it is xy, so this can be written as just on the other side, that is 2n square plus 2. This also can be written as, if x dot y, so xy cos theta. Now you can just cancel these things, this, if I just cancel it, now cos theta comes out to be 2 into 1 minus n square divided by 2 into n square plus 1. Okay, 2 into 1 minus n square divided by n square plus 1. 2 gets cancelled, so this is 1 minus n square divided by n square plus 1. That is how we get the angle. Okay, let us go to the next one. Next one, it is shown that what will be the, I'll just decrease the size little bit to accommodate in the page. Okay, it is told that what will be the projection of vector A on B, and both the vectors are given in terms of that unit vectors I, j, k. So A is given I plus j plus k and B is given I plus j only. Okay, and so the projection of A on B can be written as, I'll just write it down. The projection of vector A on B, this can be written as, this is equal to A dot B divided by mod of B dot unit vector B. Okay, that is how it is written. And so I can write that A dot B is I plus j plus k dot I plus j divided by mod of B. Mod of B, it is I plus j, so root over 1 plus 1, so it will be root 2. So mod of B becomes root 2 into that unit vector, magnitude of the unit vector, it is defined as vector B divided by mod of B. So that if you just execute this particular term, that is, if you just execute the dot product, that comes out to be 2. So 2 divided by root 2 into I plus j divided by root 2. So that this 2 by root 2 into root 2, that gets cancelled. So the answer will be I plus j. Okay. There will be lot many problems like this if we are doing all the problems from like PYQ from 2019 to 2025 onwards. So a lot of time is required. So if you guys are interested, you can request for a online live class for 1 hour consecutively for 2 or 3 days. Then we can solve a host of problems, like about 20-30 problems we can solve. Then all the concepts that we have learned for vectors will be cleared. Okay. Thank you for your patient listening. We'll come back to you for the next class. We'll be starting a new topic in the next class. Thank you.